It's in the walls, under our feet, and all around the world. Cement, the backbone of everything we build. Cement is essential, but also responsible for nearly 8% of global CO2 emissions. Most of that comes from clinker, cement's key ingredient, made by heating limestone, among other materials, to over 1,250 degrees Celsius, releasing massive amounts of CO2. The good news? Cement isn't all clinker. It's clinker plus other things. And if we want to cut emissions, we need more of them and less of it. Enter supplementary cementitious materials, the sidekick clinker doesn't want you to know about. SCMs are alternative ingredients that can replace some of the clinker in cement. They've been around for a while. Fly ash, slag, calcined clays, and they've proven their worth. But maximizing usage without compromising performance, that's the tricky part. See, cement chemistry is complex. Change the mix, and suddenly your concrete might not set right. Plus, the go-to SCMs are running low. We need new ones, and we need them fast. And that's the real challenge. How do you make new, more variable materials behave predictably at scale? Luckily, most plants already have part of the solution: data. Massive amounts of it, from sensors, labs, and control systems. What's missing is turning that data into action. And this is where DETOCS comes in. A bold project with an even bolder mission. Use data and science to cut emissions fast. It brings together sharp minds, cement chemistry, and a whole lot of solid data. Not just to optimize cement composition, but to ensure it performs in concrete too. Most projects stop at one or the other. DETOCS does both, building smart, explainable models that predict how mixes will behave, helping producers cut clinker without cutting quality. 15 PhDs, one big goal. Drop the clinker factor from 70% to 40% by 2030. From chemistry to policy, from raw materials to final concrete, each PhD is solving a different part of the puzzle. Some are focused on the ingredients themselves. They're using heat, friction, mineral carbonation, and even computer vision to understand what makes a good clinker substitute. Like Wang here, who's developing models to optimize the clay calcination process.
I'm developing models to optimize the clay calcination process.
Or Marco, who's upcycling concrete waste into SCMs and recycled aggregates. But knowing your ingredients isn't enough. You've still got to know how the mix will perform. That's what other candidates are working on. Training machine learning models to spot what drives variability, or using chemistry and data to design cement blends that are sure to hit performance targets before mixing even begins. Mikna and Thorsten are developing models that can predict the influence of process variations in both clinker and the cement quality. Sniff out problems before they hit the fan. It doesn't get any more Industry 4.0 than that. But of course, even the best blend won't help if the rules won't allow it. That's why some are digging into regulations and roadblocks, figuring out how to open the market for low-carbon cement. Go get 'em, Malik. Others are busy testing, tweaking, and making sure it all works in the lab, on paper, and on the plant floor. From chemistry to concrete, DETOCS is connecting the dots, turning data and science into low-carbon cement that actually works.